This little arrow is a vector. And by the end of this course, you'll see why almost everything around you, video games, GPS, the AI on your phone, is built out of them. Let's start at the very beginning. Before any formulas, one honest question. What is linear algebra, and why should you care? Linear algebra is the mathematics behind video games, GPS, artificial intelligence, physics, and engineering. Every time a game moves a character, or an AI recognizes a face, this is the math doing the work. And all of it is built on one single object. Linear algebra is the mathematics of vectors. So the real first question is, what is a vector? Ask a physics student, and they will say, a vector is an arrow. It has a length, how strong, how fast, and a direction, which way, a force pushing a door, wind at 30 kilometers per hour toward the east, velocity, gravity, all arrows. Ask a computer science student, and they will say, a vector is a list of numbers. This house is a vector. Price, size, number of bedrooms, your music taste, to a streaming app, is a vector too, a long list of numbers. And the mathematician says something sneaky. A vector is anything you can add together and multiply by a number. That definition covers both of the others. And that is the point. These are three views of one object, and we will switch between them constantly. Here is the everyday problem vectors solve. You have 3 apples and 2 oranges. 3 plus 2 is 5. But 5 of what? You can't add apples and oranges. The numbers belong to different things and must not be mixed into one number. But we still want to carry them as one thing. One shopping basket. So we stack the numbers into a column and treat the package as a single object. That is a vector. Each number keeps its own row, its own lane. Apples never mix with oranges. That is the reason vectors exist. Several related numbers. One object. Nothing lost. Now the beautiful part. How a list of numbers becomes an arrow. Put down a numbered grid, like the streets of a city, and stand at the origin. Take the vector 4, 2, and read it as walking instructions. 4 blocks east, the X move, 2 blocks north, the Y move, and the vector is the single yellow arrow that takes you there directly. Same information. 2 costumes. The list is the arrow. The arrow is the list. Because life adds them for us. Example 1. A walk. Morning. 2 blocks east. 1 north. Watch it built. After lunch. 1 more east. 3 north. Starting where you stood. Where are you? Compared to home? The numbers answer lane by lane. East lane. 2 plus 1 is 3. North lane. 1 plus 3 is 4. And the green arrow agrees. Straight from home to where you stand. Adding vectors means, do one trip, then the other. The sum is the shortcut. Example 2. From physics. You row straight across a river. But the current pushes you sideways at the same time. Nature adds the 2 velocity vectors whether you like it or not. Your true path is their sum. Pilots and sailors compute exactly this every day. Example 3. From data. A fruit stand. 12 apples and 5 oranges Monday. 8 and 7 Tuesday. The week's total is the vector sum. Each lane added separately. Spreadsheets do vector addition all day long. The second move. Scaling. Multiply a vector by an ordinary number, a scalar, and every component gets multiplied. Here is versus equals 2. 1. With a live dial for C. C equals 2. Same direction, twice the length, the same road, twice as fast, or a doubled recipe. C equals 1/2, half speed. And C equals -1 flips the arrow. Same length, exactly backwards. Your morning route, walked home in reverse. What about subtraction? Nothing new, and that is the lesson. V minus W means versus plus -1 times W. Addition plus scaling are same 2 moves. The life question it answers. Where is something compared to me? You at 1, 1. Your friend at 4, 3. Subtract lane by lane. 3, 2. The green arrow drawn from you to them. V minus W always points from the tip of W to the tip of V. The same subtraction measures any change. This week's sales minus last week's. Final velocity minus initial. How many numbers can a vector hold? 2. Pin down a point on a flat map. A drone needs 3. East, north, and height. Still easy to draw. Now the house from earlier. Price, size, bedrooms, year. A 4-dimensional vector. And a streaming app describes your taste with hundreds of numbers. Nobody can draw 4 perpendicular directions, let alone hundreds. And the algebra does not care. Add lane by lane. Scale each lane. The rules you just learned work in any number of dimensions. Your 2D mental picture stays correct in dimension 100. Now combine the two moves. Some amount of one thing plus some amount of another. Like mixing paint. 2 parts red plus 1 part blue gives one particular purple. Every mix you can pour is some combination. With vectors it is the same idea. C times versus plus D times W. Scale each vector. Then add. This is called a linear combination. The single most important expression of the course. Watch the green point. It marks C versus plus DW while C and D run through different values. With just 2 vectors and 2 dials, the point reaches anywhere on the plane. 2 directions are enough to deliver you to every address in the city. Which targets can be reached? That question leads straight to matrices. One preview before we finish. Take 2 vectors, V and W, and stand them side by side as the columns of one box of numbers. That box is a matrix. Several vectors filed together, and it becomes a machine that acts on vectors. Every question of the form, which combination reaches this target, becomes the tidy equation AX equals B. Solving it is how GPS locates you and how neural networks learn. Matrices are coming in the next chapter. What to remember. A vector packages related numbers into one object. A list, an arrow, and a point at once. Vectors add lane by lane. And life adds them for us. Walks, forces, sails, scaling stretches, shrinks, or reverses. Subtraction measures the gap. The same rules run in any number of dimensions. And combinations C versus plus DW reach everywhere. Matrices organize that power. If you remember one sentence, make it this. Linear algebra is the art of adding and scaling. The next videos take each of these ideas one at a time. Slowly. See you there.